Hello children, welcome to my dream. Today we are talking about the rotational mechanics and we also compared with the translatory motion. So let us start with the rigid body. What do you mean by the rigid body? What is the translatory motion? What is the rotational motion? So if an external force applied to a body, if an external force applied to a body does not produce any displacement of the particles of a body relative to each other, that is called a rigid body. Suppose you are applying an external force on an object, that is made of so many particles, does not produce any displacement of the particles of a body relative to each other. That is called rigid body. No real perfectly rigid body leaving rubber, etc. Yes, the relative displacement of the particles, of the particles of a body when we are talking about the relative displacement of the particles of a body is very small, so we can neglect it. The force. So if any external force is applied on an object that does not produce any kind of the displacement of the particles of a body relative to each other, that is called rigid body. Translational motion. What do you mean by the translation motion? A rigid body performs A rigid body performs a motion if the particles undergoes the same displacement in the same direction in the given interval time, whatever the time is given to you, given interval of time, that is called translational motion, a translatory motion. If the particles undergoes the same displacement in the same direction in a given interval of time, that is the translational motion. Understand? Rotational motion. A rigid body performs a motion if the particles of a body moves in a circle. When the particles of a body moves in a circle and the center of all the circles, lies in a straight line. In this case, when we are talking about the translation motion, the particles of the medium undergoes the same displacement in the same direction in a given interval. Whenever we are talking about the rotational motion, the particles of the body moves in a circle and center of all the circles lies in a straight line. So this is the difference between the translation and the rotational motion. Let us talk about the torque. What do you mean by torque? The amount of work required to rotate an object at their own axis. The amount of work required to rotate an object at their own axis, that is called torque, or you can say moment of force. Or you can say torque. It is a vector quantity. Torque is equals to force into perpendicular distance. Greater is the perpendicular distance, lesser be the force applied. Greater is the perpendicular distance. As you see the fan के जो blades अगर लंबे होंगे तो force कम लगानी पड़ेगी. If you want to do the couple dance, हाथ लंबे होंगे तो force कम लगानी पड़ेगी. हाथ छोटे होंगे तो ऐसे लगेगा लड़ाई हो रही है. Yes, angular acceleration. Angular acceleration, the rate of change in angular velocity which gives the angular acceleration. If you want to discuss the instantaneous angular acceleration, then you can write down limit tends to 0 del omega by dt. Yes, as you know about the v is equals to r omega, if you want to differentiate this with respect to t, then you will write down. So this is the linear acceleration and this one is the angular acceleration. So alpha can be write down a upon r. Next. Now we are talking about the comparative study of translational and rotational motion. Translational motion, rotational motion. कंपैरेटिव स्टडी ऑफ द ट्रांसलेशनल एंड रोटेशनल मोशन से आपको बहुत हेल्प मिलेगी. अगर आप रोटेशनल में कुछ भूल गए, आप कंपेयर करके याद करेंगे, वो अपने आप आपको याद आ जाएगा. मास इज द मेजर ऑफ ट्रांसलेशनल मोशन. Mass is the measure of translational motion, whereas moment of inertia is the measure of rotational motion. It means without moment of inertia we can't discuss the rotational motion. Without mass we can't discuss the translational motion. इसमें मास है, इसमें moment of inertia which is represented by I. Now, in this case we are talking about the linear momentum, whereas in this case we are talking about the angular momentum. So in place of mass you can write down moment of inertia. In place of velocity you can write down angular velocity. Yes, if we are talking about the kinetic energy, that is given by this translatory. Kinetic energy कौन सी rotatory? In place of mass you can write down I. In place of velocity you can write down omega square. Kinetic energy in terms of momentum is given by P square by 2m. Kinetic energy in terms of angular momentum. So in place of P, you can write down L. In place of mass, you can write down I. Here, you are talking about the force. The rate of change in momentum gives the force. Rate of change in linear momentum is called. Here, force की बातें नहीं हो रही. Torque. The rate of change in angular momentum. The rate of change in angular momentum. That gives. Here we are talking about in case of the translational motion, here we are talking about the conservation of momentum. If no external force is applied on an object, then the momentum is conserved, you know. If no external force is applied, then the momentum remains constant. But here it is, when we are talking about the rotational motion, if no external torque is applied, then the momentum is conserved. As you know, L is equal to I omega. I1 omega 1 is equal to I2 omega 2. Here we are talking about the force torque. It means इधर मास है तो बेटा इधर क्या है? मोमेंट ऑफ इनर्शिया. मोमेंट ऑफ इनर्शिया ऑफ द रिंग आपको बता देते हैं शुरू में. ऑफ द डिस्क of the cylinder of the solid sphere thin cylinder. Spherical shell. लर्न कर लीजिए आप, वैसे हम ड्राइव कर देंगे आपके लिए. इधर मास है, इधर मोमेंट. नाउ एक होता है रेडियस ऑफ गायरेशन. रेडियस ऑफ गायरेशन I is equals to mk square. K can be write down I by m. Yes, a point on a system of the particles act as an axis of rotation, that is the radius of gyration, which can be write down like this also, r1 square r2 square by m. And moment of inertia क्या होता है वो भी सुन लीजिए. Moment of inertia is defined as it is the product. It is the sum of the product. It is the sum of the product. Sum of the product It is the sum of the product of the mass of the particle and the square of the distance from the axis of rotation. Suppose, as you know, this is a particle whose mass is m1, this is m2, say this is m3, and their perpendicular distances from the axis of rotation be r1, r2, r3. That is. So this is given by I is equals to m1 r1 square plus m2 r2 square, m3 r3 square up to, which can be written I is equal to mi ri whole. So the moment of inertia is defined as it is the sum of the product of the mass of the particle and the square of the distance from the axis of rotation, that is called moment of inertia. Generally आप ऐसे भी लिखते हो, yes. Now we are talking about the rolling. Rolling अच्छा टॉपिक है, वो ले लेते हैं पहले. रोलिंग, प्योर रोलिंग. On an inclined plane, not sliding. Suppose this is the inclined plane. Here it is an object at a height h. It makes an angle theta. As it reaches the bottom, इसके पास एक अपनी एंगुलर वेलोसिटी है और एक बेटे कौन सी है, लीनियर. Yes, this object rolls, not sliding. Here it is at the top. Kinetic energy क्या है, 0. Initially that is at rest. And the potential energy is mgh. But as it reaches the bottom, linear velocity as well as the angular velocity, both of them. So translatory as well as the rotational kinetic energy, which is given by half mv square plus half I omega. Then according to conservation of energy, total energy at the top and the total energy at the bottom. Bottom पर potential energy 0. So 0 plus mgh is equal to half mv square, which is half I omega. So in place of this, one by 2 mv square. In place of this, you can add on mk square. अभी थोड़ी देर पहले पढ़ाया. In place of omega, you can add on b by r. Then you will get that is half mv square, half mv square. So mgh is equal to half mv square 1 plus k square by r. So v square is equal to 2gh divided by 1 plus k square by r square, and v is equals to twice of gh divided by 1 plus k square by r square. This is the displacement S. Note, इसको आप साइन थीटा के टर्म्स में भी लिख सकते हो. h अपॉन s, h इज इक्वल टू s साइन थीटा. टू जी एस. बट माय डियर, एक बात मैं आपको क्लियर कर दूं. Linear velocity is independent to the theta because at a certain height से उसे थ्रो किया गया. अब ये हाइट यहां होती तो ये भी तो चेंज हो जाता. ये हाइट तो एंगल तो उतनी, हाइट तो उतनी. सो it is independent, it is independent to the theta. जो एंगल ऑफ इंक्लिनेशन है उस पर डिपेंड नहीं करता. नाउ द क्वेश्चन इज दिस, इफ देयर इज अ प्रेजेंस ऑफ स्फीयर, रिंग, डिस्क, who will reach first? Who will reach first? A sphere, already sphere is given to you, a ring is given to you, a disc is given to you, a cylinder is given to you. So which one will reach first? पहले उसको देख लेते हैं, फिर आगे. As you got V is equals to under root 2i of gh 1 plus k square by r. एक और नोट लिख देते हैं. For sliding, if the object is sliding, then k square by r square is equal to 0. Then you know क्या आ गया, देखा हुआ लग रहा है. देखा है ना, v स्क्वायर इज इक्वल टू u स्क्वायर प्लस 2gh, इनिशियल वेलोसिटी 0. तो ऐसे तो खींचते हैं उसको. ध्यान आ गया. इट मीन्स थीटा पे डिपेंड नहीं करता. नाउ फॉर रिंग, if we are talking about the ring, the moment of inertia of the ring is I is equals to mr square, and I is equals to अभी थोड़ी देर पहले पढ़ाया था. So k square by r square to 1. So V is equal to under root twice of GH divided by 1 plus 1, then you will get GH. For disc or cylinder, thin cylinder, the moment of inertia is given by mk square, and the moment of inertia, that is half mr square. So k square by r square is equal to 1 by 2. Then you will see V is equals to under root twice of GH divided by 1 plus 1 by 2, that is 4GH by 3. It means in cylinder के कंपैरिजन में ये जल्दी पहुंच जाएगा. नेक्स्ट सॉलिड स्फीयर. अब जब ये जल्दी पहुंच जाएगा तो टाइम इसको कम लगेगा, ऑब्वियसली. So I is equals to mk square, and the moment of inertia, as I told you before, that is mr. So k square by r square is equals to 2 by 5. Then you will see twice of GH divided by 2 by 5, then you will get 10 by 7, which is the highest one. So the velocity of a sphere सबसे ज़्यादा, उसकी क्या आई थी रिंग की, अंडर रूट GH. उसकी क्या आई थी 4 by 3, 1.33. So you can write down like now. As you know, V square is equal to U square plus 2AS. ठीक है. अभी पढ़ा था आपने साइन थीटा इज इक्वल्स टू एच अपॉन एस. सो एस इज इक्वल्स टू एच अपॉन साइन, ऐसा कुछ था. सो V is equals to twice of GH divided by 1 plus k square by r square. There is a square, इसलिए square root cancel. Twice of AS, S, that is H upon sin theta. So you see, S से H cancel हो जाएगा, 2 से 2, फिर भी आपके लिए अलग. Twice of GH, 1 plus k square by r square. This is twice of AH. So acceleration is equal to G sin theta, 1 plus k square by r square. As you have already read the laws of motion, work power energy, there is a sliding on a frictionless inclined plane और friction है. For sliding, the value of k square by r square, that is 0. तो आपको आता था ना, g sin थीटा का कंपोनेंट क्रिएट हो जाता था, आपने देखा होगा बेटा, यहाँ बनाते थे आप, जैसे g sin थीटा This is G cos theta. This is theta, this is theta. So that is for sliding. This is for rolling. Yes, this is for sliding. You see, note करेंगे, when we are talking about the velocity, linear velocity, velocity is independent to the angle of inclination. But my dear, the acceleration depends upon the angle. Acceleration depends on the angle of inclination. ठीक है, नेक्स्ट. अभी आपने देखा था क्या आया, एक्सेलरेशन इज इक्वल टू जी साइन थीटा, दैट इज 1 प्लस के स्क्वायर बाय आर. फॉर रिंग, अभी आपने पढ़ा था फॉर रिंग के स्क्वायर बाय आर स्क्वायर दैट इज इक्वल टू 1. तो रिंग के लिए हम लिख रहे हैं जी साइन थीटा बाई 2, 1 प्लस 1 2. फॉर डिस्क के स्क्वायर बाई आर स्क्वायर दैट इज इक्वल टू 1 बाई 2. एक्सेलरेशन दैट इज जी साइन थीटा 1 प्लस 1 बाई 2, which will become 2 by 3, which is more. For solid sphere, k square by r square, that is 2 by 5. So acceleration will become g sin theta 1 plus 2 by 5, then you will get 5 by 7. Which is more? Yes, this is note. Acceleration. मजा नहीं आया, इरेज करो. Acceleration in rolling and sliding depends on theta. यानी कि जिसका एंगल ऑफ इंक्लिनेशन, सपोज मैं ऐसे बना देता हूँ, एक यहाँ है, एक यहाँ है, हाइट सेम है, इसका थीटा 1 है, इसका थीटा 2 है, इसका थीटा 3 है. Here theta 3 is greater than theta 2, which is greater than theta 1. So acceleration for this is more. Which one will reach first? In same cases, the velocity remains same, because ये तीनों के तीनों जो हैं यहाँ पर जो velocity attain करेंगे, which velocity? Linear, that is same, because it is independent to the theta. Now we are talking about the time. This is 0, this is the displacement s, अभी बनाया था. This is the height h. So a, you know, g sin theta divided by 1 plus k square by r square into 2. So t square is equals to t square. That's सही है. u equal to u plus at से भी कर लेते. Twice of s 1 plus k square by r square upon g sin theta. Then you will see क्या पता लगा बेटा, इससे ये पता चला जिसका एंगल कम होगा उसमें टाइम ज्यादा लगेगा. एंगल कम किसका है? इट टेक्स मोर टाइम. ठीक है. सो T1 is more than T2 which is greater than T3. Lesser be the angle of inclination, more time required. Next, rolling against friction. As the object rolls, this is mg sin theta, you know. This is mg cos theta, you know. This is a normal, and here it is force of, and that is moving with this acceleration. So mg sin theta minus this is equals to m. n is equal to mg cos theta n minus, ऐसे भी लिख सकते हैं. Now as it rolls, torque due to the friction, the torque is due to this, and you know, in terms of moment of inertia, that is it. So the Fs is equals to आपको बताया था, क्या बताया था? A is equal to R alpha, the relation between the linear and the angular acceleration. So in place of alpha you can write down A by R. Here R is capital R. This is the force of friction. So this is the equation first, this one is second. So you can put the value here in equation first, that is I A upon R square, which is equal to MA. mg sin theta is equal to MA plus this A. MA कॉमन नहीं ले रहे अभी हम, अभी लिख रहे MK स्क्वायर. MA कॉमन ले लीजिए बेटा, 1 plus k square by r. 1 plus k, that is mg sin. So acceleration will become g sin theta. आ गया बेटा भाई. Yes, if you want to discuss the F is equal to mu n पढ़ा होगा आपने. F is equal to mu r and n that is equal to mg cos theta. Yes. Now we are talking about the conservation of momentum, conservation of angular, conservation of angular momentum. As I told you before, when we are talking about the translational motion, if no external force is applied on an object, then the linear momentum is conserved. But when we are talking about the angular momentum, if no external torque is applied, if no external torque is applied, then the angular momentum remains conserved. Yes. As the momentum is conserved, so L is equals to a constant, delta L. So I1 omega 1 is equals to I2 omega 2. Yes. Now we are talking about the moment of inertia. Moment of inertia. Moment of inertia of a ring passing through the center, and perpendicular to its plane. Now we are talking about the moment of inertia of a ring, uniform ring, passing through the center and perpendicular to its plane. Yes. Here it is. There is a ring whose mass is capital N and the radius is capital R. We are assuming a small element whose mass is delta M and the length is delta X. When we are discussing the moment of inertia of the different bodies like ring, disc, solid cylinder, rod, these are based on the distribution of mass. This is a uniform ring. the capital M mass is distributed over the periphery, over the circumference, and that is 2 pi r. So linear mass density discuss हो रही है, linear mass density, because this capital M mass is distributed on this circumference, that is 2 pi r. 2 pi r is the length, or you can say the distribution of mass over the one coordinate out of the three coordinates. The distribution of mass per unit length. So here M mass कितनी लेंथ पर डिस्ट्रीब्यूट हो रहा है, एंड डेल्टा एम कितने पर हो रहा है बेटा, डेल्टा एक्स पर, एंड दिस इज द डेल्टा एम, दैट इज द मास ऑफ द एलिमेंट, that is m upon 2 pi r into dx. And you want to know the moment of inertia of this element. You want to know the moment of inertia of this element passing through the center and perpendicular to its plane. ठीक है, वाई ओ वाई डैश ले लीजिए. Then you can write down moment of inertia is given by delta m, and radius you know, and the limit is, this is the element, the maximum limit क्या हो गई, 0 to 2 pi r. And delta I is now written as m upon 2 pi r into dx into r. This is the limit. Delta I will become I, m upon 2 pi r square, अभी ऐसे ही लिख देते हैं, 0 to 2 pi r. So delta I will become I. This is 2 pi r. This is x. So m r square divided by 2 pi r, upper limit minus lower limit. Then you will get the moment of inertia of a ring, that is mr. Once again I am telling to you, if we are discussing the moment of inertia of the different object, you must know the distribution of mass. The next question. Now we are talking about the moment of inertia of the disk passing through the center and perpendicular to its plane. Here we are talking about the moment of inertia of the disk passing through the center and perpendicular to its plane. This is a disk having the radius capital R, and you are using this element which is at a distance x. There is a small element, आपने ये ऐसे बनाइए, और that is dx. This is x, and this is the axis of rotation. So in this case, when we are talking about the disk or a coin, सो द मोमेंट ऑफ इनर्शिया कौन सा लेंगे बेटे? सरफेस मास डेंसिटी, द डिस्ट्रीब्यूशन ऑफ मास पर यूनिट एरिया, द डिस्ट्रीब्यूशन ऑफ मास ओवर द 2 कोऑर्डिनेट आउट ऑफ द 3 कोऑर्डिनेट. सो कैपिटल एम डिस्क का एरिया कितना होता है बेटा? पाई आर स्क्वायर. दिस इज द स्मॉल एलिमेंट डेल्टा एम. ये तो लेंथ हो गई इसकी, कितनी लेंथ हो गई? 2 पाई एक्स. ये इस पे बनाओगे ना पूरा ऐसे. 2 पाई एक्स इज द लेंथ एंड विड्थ कितनी हो गई? dx. So delta m will become m into 2 pi x dx divided by pi r. So it will become twice of m x dx. So delta m. And you want to know the moment of inertia. Moment of inertia of this small element passing through the center and perpendicular to its plane. Then you can write out delta m into यहां से यहां तक का कितना डिस्टेंस है आपके पास? r नहीं है बेटा, x है. So delta I, that is 2m x dx yes upon r square into x square, this one. So 2m by r square x cube dx 0 to r लिमिट लेंगे. क्यों? अभी तो आप इतना ले रहे हो ना, पूरा कितना होगा? डिस्क तो पूरा फैला हुआ है, डिस्क तो पूरा है ना बेटा. कभी आप 0 to 2 पाई आर ले लो. डेल्टा आई विल बिकम आई x की पावर 4 डिवाइडेड बाई 4 limit 0 to r. So it will become 1 by 2 r raised to power 4 minus 0 divided by r square. Then you will get half m r square. ठीक है? इसी में मैं एक और बता देता हूं आपको. If we are talking about the moment of inertia, moment of inertia, इसी में बता देते. Moment of inertia of a thin cylinder, thin uniform cylinder, इसी में बता देते. ये हो गया जी सिलेंडर. अब ये आपने ऐसे बना दिया. अब क्या हो गया? ये लेंथ हो गई. अब थिन सिलेंडर है तो इट मीन्स लेंथ है, विड्थ है, हाइट है, 3 कोऑर्डिनेट में. तो यहां क्या कर देंगे? नेक्स्ट पेज पर यहां से बता देता हूं मैं आपको. यहाँ बता दो. दिस इज द डिस्क. नाउ इट विल बिकम सिलेंडर. आपने एक कॉइन ले लिया, 2 कॉइन, 10 कॉइन, और वो क्या बन गया? एक सिलेंडर. ये हो गया ये कैपिटल आर. ये आप ऐसे बना लीजिए, ये ऐसे ड्रॉ करिए. ये dx है, ये यहां से यहां तक का x है, और ये लेंथ है. तो डिस्ट्रीब्यूशन ऑफ मास पर यूनिट वॉल्यूम. कैपिटल एम मास का सिलेंडर है और बेटे पाई आर स्क्वायर, तो ये हो गया बेटा और ये हो गया, डेल्टा एम हो गया, लेंथ कितनी है 2 पाई एक्स, विड्थ कितनी है डी एक्स और हाइट कितनी है, लेंथ से लेंथ कैंसिल हो गया। देन यू सी यही किसमें लिखा था आपने, यहां लेंथ से लेंथ में मोशन कैंसिल हो गया, तो मोमेंट ऑफ इनर्शिया इसका भी कितना आएगा, इसका मोमेंट ऑफ इनर्शिया भूल जाएगा। इसके बाद जो भी आप स्टेप करेंगे दैट इज सेम, लाइक 2m by r square limit 0 to r x cube dx, it will become half m r square, x raised to power 4 हो जाएगा divided by 4 and you can put the limit, then it will, यानी कि मोमेंट ऑफ इनर्शिया ऑफ द सिलेंडर, मोमेंट ऑफ इनर्शिया ऑफ डिस्क सेम है। नाउ so now we are talking about the total energy. Total energy in case of rotational motion. Total energy in case of rotation. Total energy is given by kinetic energy by translatory, kinetic energy by rotation. And kinetic energy is given by this. I is equals to this half mv square half mk square v square by r. Then you will get v square 1 plus k square by r. This is the total energy. This is the total energy. Yes, for ring के लिए डिस्कस कर रहे हैं, k स्क्वायर बाई r स्क्वायर इज इक्वल्स टू 1, आपको बताइए mk स्क्वायर इज इक्वल टू mr स्क्वायर. So the total kinetic energy for the ring, that is yes, it will become mv square for disc or cylinder, for disc or cylinder, for disc or cylinder. The value of k square by r square is equal to 1 by 2. So kinetic energy for this, total kinetic energy, total kinetic, यहाँ आपको लिखना है टोटल काइनेटिक एनर्जी, ये भी लिख दोगे कोई फर्क नहीं पड़ता, पता तो है ही आपको। टोटल काइनेटिक एनर्जी that is half mv square 1 plus 1 by 2, that is 3/4. Yes. In the next session, I will discuss the problem based on the rotational mechanics. Okay.